Sorry, this is John.
Well, I'll take it.
Yeah, sorry.
Okay, thank you. Yeah, I can't figure out this issue.
Since we don't have class this week, this sad face here is not, it is because, you know, I will miss you terribly. Actually, it's because us teachers still have to work, but anyhow, you can feel sorry for us. Because we thought whenever that schedule came out at the beginning of the semester, and we were like, spring vacation. What's spring vacation? That sounds like a really good idea. I'm liking the idea of spring vacation. And then about 2 weeks ago, we got this email that was like, scheduled for Thursday. What? What? I thought that I was coming to spring vacation that day, so it was a bummer. Luckily, I hadn't made a lot of plans. I could be planning on being in New Orleans or something. That would be a problem. This is a great time of year to go. I haven't gotten to go down and see my daughter for like 2 years. So we're looking at chapter 30. In chapter 30, we're really getting out of our book, and we're starting to look at some networking things. So these are really our 3 advanced chapters. I'm going to bring up the Ravel stuff because I want to show you where you can find this so-called chapter 30. Because if you look at the table of contents for our textbook, you'll see that it ends at chapter 29. We didn't do every single one of those chapters. A lot of them, though. So chapter 30 is going to be in this infamous supplemental material. So let's take a look at that. And we want the web chapters. So down at the bottom, if you notice, they have web chapters, chapter 30 to 43. So good things and bad things about this. First of all, if you'll click on chapter 30, you'll see each chapter is its own PDF. So if you were wanting a hard copy, this chapter is finally conducive to doing that. You can just print this out. That means that it doesn't have a lot of the cool links and hyper connected things that we're used to from our other chapters, because it's just a leftover extra chapter. So for chapter 30, the reason I want to take a quick look at it today and what we have in chapter 30 is because your assignment that's due next Tuesday, a week from today, requires this multi-threading. It's a really small assignment, but it can be a gotcha assignment. You know how some of those are. So it shouldn't take you a huge amount of time, as long as you know what to do when you're getting started. If you don't, then it can really bite you and take a long time. So let's talk about multi-threading and parallel programming so that we're ready to do this. The presentation that I have is the parallel processing one. You can see there's several, because we really have quite a few different topics with this first topic of networking. So when I'm talking about a parallel processing or multiprocessing, does that have anything to do with networking? Kind of a whole lot, right? Because what if I have 7,000 Raspberry Pis all set up and I'm trying to do some calculating of the next prime number that's over 100,000, that's going to give me all that money. Those are network devices that I'm going to do parallel processing or split up my processing amongst them. So it could be a networked component type thing. That's how it started. We think now about parallel processing as being one processor with multiple cores, where I can have processes executing on those different cores concurrently. So let's look at our processes display. How do you get to this on Windows? Control-Alt-Delete, then what? Find it. Alt-F4 it.
Oh, Task Manager.
Task Manager. So go there. Now, as a computer user that's entering the IT field, Task Manager should be a very familiar application to you. If it's not, get started making it be so.
I watched that run, the exam. Used almost 40% of the CPU.
Did you wipe it out? And that's an exact reason why you want to be familiar with Task Manager. We can find some performance statistics here. So let's click on more details, because I want to actually find the processes that are running on my machine. Now with Windows 10 and all the advanced security, you might not actually be able to see all of the processes that are running on your machine, depending on your administrative rights and the administrative rights of some background processes. So it can be a little less clear than it used to be. But basically, if I look at all of these processes are running on my machine. Right now, I'm running PowerPoint. So I see my PowerPoint says that it has two child processes. So I'm going to click the triangle to expand that. And I see that I am running my PowerPoint that's displaying and then the slideshow part. So it basically is considered two tasks. So each of these processes are things that are running on the computer. Right now, they're not using any CPU. They're using some memory, not really using much disk interaction. But my performance numbers are showing right here in Task Manager, where I can see, if I were running my Java program, I could see how much resources it was using. So each of those are a process. Okay, so Task Manager, really important. I'm going to close that. So that's what we're referring to when we talk about processes that are running on the machine. Things that are requiring resources. Now again, in this example, PowerPoint has two threads because a thread is a task that's being run as part of that process. An application could have many, many threads active. That's called multi-threading. So this picture is from our book. Here we say we could have 3 threads. In the beginning picture, A, each thread has a separate processor. I have 3 cores or 3 separate processors in this machine, probably 4, probably not 3. But each of my threads can be allocated to its own processor, begin processing, run, and finish. Now in B, the threads are sharing a single processor. They have to use time sharing. So we don't really get super aware of that, right? But we know behind the scenes, the processor is being sliced up and resources are being shared amongst all of the active threads. So here, thread 1 got the processor for a bit, then thread 2, then thread 3, thread 1, thread 2, thread 3, thread 1, thread 2. Nice, nice round robin. We give some time to each one, and then we continue on. Now, when we're working with Java, we actually have the ability to spawn off threads so that we can have different threads doing different things running at the same time. So for us, what we need to be concerned about is that we're going to be using the Runnable interface. And every time we spawn off a thread, that's going to be a runnable object. So these threads are going to be set up for us to run a task in Java. So let's look at listing 30-1 and create this one real quick. It's really fast. It's not going to keep you from getting to your group project for too awfully long, but it's a really good one for us to take a look at together so that you're ready to do that assignment. I'm going to get NetBeans open while I find that thing. Don't forget, you guys, I know most of you are like experienced veterans, but let me know if you want to look at your schedule or your plan or do any sort of advising. I think I'm some of you's advisor. You may have already gotten that taken care of or be putting it off as long as possible. But let me know if you want some help. All right, so NetBeans is finally open. That's what I wanted. I'm going to create a new project. And I'm going to do next. Oh, yeah, and then some of you might be interested in the C#2 classes. C#1 and C#2 will both be offered over the summer as online, 5-week only classes. So if you want to get C#1 out of the way and you have had Java 1 and 2, you're probably going to be able to whiz right through C#1 in that 5 weeks without any problem. You are going to have to dedicate a lot of time to it because you are getting a lot of material in that 5 weeks, but you guys would probably be able to get through it without any problem. C#2, you might want to wait until the fall semester to take, but if you get C#1 out of the way in the summer, then you would be all ready to take it in the fall. Or you could take both of them in the summer if you want. Also, you could do WebDev 1 and WebDev 2 over the summer as 5-week offerings. So like if you've already had WebDev 1 and you want to do the WebDev 2 and try to get it out of the way really quick, you could do that. So they're really high-speed courses that move very quickly, but if you have the experience and the background, it's a great opportunity to get them onto your transcript and off of your to-do list. Okay, so for listing 30-1, I'm going to create this project as listing 30_1, and then I want my main class to be named Task Thread Demo. Surprisingly enough, there's already like 7 or 8 people in that C#1, so it will probably make. So jump in there if you want. I hope they don't keep letting people add. Last year, they just let people add, and we ended up with 6 or 8 people that were out of the country, and it was a very hard class to teach with people all over the world. Are we ready?
So the 5-week class.
Uh-huh.
Is that going to be pretty advanced for me then?
It's pretty quick. I don't think so. I'm trying to think of who took it. We don't have anybody in here that took it last summer, so I'm not sure who to ask. I think you would be okay, but you stress. I don't want to make you stress, but I think you are okay. Oh. No. With your Java experience, I think you would move through it very quickly. Okay, so here I've got my project finally ready to create. And we're going to be kind of stepping away from some of the other things that we've been looking at recently. For our task thread demo, we're going to be having some different classes, but we'll be, what am I trying to say here? Let me spit it out. We'll be putting the majority of our logic in our main. So for our main, first we want to create our tasks. We said they would be a new instance of a runnable. Now the runnable is going to require an import let me get back to where I'm sorry. Okay, so what we want to do is we're going to set up 3 different tasks to print things out to the screen. So let's set those up. First, we're going to have print A. And this thing is going to run PrintChar. We'll create that here in a second. And it's going to print out 100 char characters, the letter A. That's what print A is going to do. Now we want to create another runnable task. It's going to be print B. It also is going to be a new instance of this PrintChar thing that we haven't created. And it's going to print out the letter B 100 times. Then we want print 100. It's going to run a different method that we also have not created yet, called print num. It's going to print out all the numbers to 100. Now in our main, after we create these runnable instances or runnable tasks, then we've got to create threads to hold our tasks. Run the tasks with them, basically. So we're going to create an instance of a thread. Thread 1 will be a new thread of that print A method. Thread 2 will be a new instance of the print B method. Thread 3 will be a new instance of our print 100. So we created a task. In this task, I want to run this PrintChar method, and I want to call this task print A. It's a runnable task. Then I create a thread to hold that task, kind of like a pipeline to push it through. Finally, I can start up the threads. Now, when I start the threads, they're going to each run the task they've been assigned to. Now that's going to end our task thread demo class. We have everything in it that we need to demonstrate creating these multiprocessing threads. So now we need to create this PrintChar. So it's going to be a class, PrintChar, and it's going to implement Runnable. Runnable being the interface that allows us to implement multi-threading. We need a couple of variables in our PrintChar class to control all of this. We're going to use a private char named char2print. And this is going to hold the character to print. Then we're going to have a private integer that holds the number of times to print. Now within our PrintChar class, we're going to create a constructor here. This constructor is going to create a task, construct a task with a specified character and number of times. So in our constructor, when someone says they want to do this PrintChar thing, we've got it up here. We see that we need to accept the character and how many times they want to print it. So let's create that constructor, public PrintChar. We have a parameter that's a char variable. We'll call it C. We have a parameter that's an integer. We'll call it T. Our char2print variable is going to be initialized with the value of the C argument that was passed to us. And our times will be set to T. Now, because our PrintChar class implements the Runnable class, we have a method called run that's available or must be implemented by the Runnable. Let's mouse over this PrintChar name and you should see that message. It does not override abstract method run in Runnable. So we need to create that run method. It will be an override, of course. Now our run method does not expect any parameters. So our run method is going to include a for loop. We're going to set up an integer named I, starting at 0. And we're going to run while I is less than that times variable. And we're going to increment I each time we execute our for loop. Within our for loop, the only thing we're going to do is print that char to print value. So the PrintChar method takes care of printing out our characters for our first 2 threads, but we need something for our number. So let's copy our whole PrintChar class. So be careful here. I'm going to select the whole PrintChar class and copy it. And then I'm going to paste it. And this is going to become print num. We don't need a char to print variable at all. We do need an integer though. And we're going to call this integer last num instead of times. And it will actually be the last number now our constructor is going to be a little different. Our constructor is just going to construct a task with a specified number. I don't really need that second line of comments. So my constructor needs to match my class name. So I'll have to change it from PrintChar to print num. And then I only want an integer. And they called that integer n. It doesn't really matter that much here, but we'll fix it. Now we want to set n, or use n, to set our last num. So now for our override of the run method, remember this run method is basically containing the code that we want to execute as this task. So we're in our run method here. We're going to run the loop while I is less than last num. And we're going to change it to print, not print ln. And what we want to print is, oops, off in the wrong spot on my keyboard. We want a space plus the value of I. And I see that problem in the run method we created for our PrintChar. Make that statement a print statement instead of a print line statement also. Okay, so now we've set up these 3 tasks. We've set them up as threads. We've used a class that implements the Runnable and created a run method that is the code we want to run for these tasks. We should be able to run it now. Let's try it. We should see 100 of the letter A, 100 of the letter B, and from 0 through 100.
Can I see the
Mm-hmm. So why are they all mixed up? Yeah, they're running together. So we're getting the same thing. Did I have higher priority? Okay, so this one is a simple, as I said, a simple multiprocessing. You see it gets complicated really quick, doesn't it? So first we have to create our tasks. Then we have to load up a thread with the task. And then for our thread, issue the start method so that it starts up that thread. Now, if you look at it, thread1.start says, oh, thread 1 is running the task print A. So print A says, oh, I'm running the PrintChar class. So I go to the PrintChar class and I see that the PrintChar class implements the runnable. So I'm looking for the run method. The run method runs and gives me the output. Now, your assignment, like I said, we wouldn't spend a lot of time here today looking at this. We'll look at that presentation a little bit more. But your assignment is to make one of the animations multi-threaded, raising the flag. Now, there's a really important point to remember in this assignment. Whenever you're using Java FX, can your stage run on any thread? Your stage is always the primary thread. So that's a really important point as you're working on this assignment. This assignment will have about 7 lines of code. They're just really important lines of code. So if you're having trouble with it.
I had to miss something someplace.
7 to 10, it's really short. Yeah, because it's all multi-threaded.
Yeah.
So they're running concurrently. That's what you want. That's what you want. Mine does different. Yeah, so see, mine's just scattered differently.
Mine looks here.
So yours is what? All mixed up?
Yeah.
Good. We want it to be all mixed up. That's good.
I went ahead and put spaces in up at the top.
Yay!
Too,
So it's all pretty, pretty, pretty.
So it's kind of.
Kinda. Okay, so when we're talking about multi-threading, we're talking about using that runnable interface, which means everything we put in that run method is what's going to happen as part of this multi-threaded task. So remember, things do matter when we're doing multi-threading. I can't start up one thread that deletes an employee and then start up another thread that adds an employee. Not if it's the same employee, right? So I need to make sure that my threads are doing things independently of each other so that they're not affecting each other. And if I do have to impact, I have to make sure that the sequence is appropriate. So that's still my thing, my control. These tasks are executing concurrently. If we used run instead of start, the tasks wouldn't be started in new threads and they would just run side by side. So it's a very simple thing. What's wrong with this one?
It's missing the keywords.
You're right. Yeah.
The main difference is we have 2 classes and this one's called 1 and all third one class. and remains inside the same file.
So when do we ever create our thread right there? New thread, dot start, we're running it. We'll try it. I'm gonna skip it for now because I know we don't care too much about what's wrong with it right now. We have all that group work and stuff to do. I'll get all that information ready for you for next time so we can look at it. Whenever we're looking at the thread, remember we're looking at a thread class. And the thread class has these capabilities and functions available to it. You can start the thread. You can check to see if it's alive. You can set its priority. You can join it. You can cause it to sleep, yield, or interrupt. These are all things that we need to be aware of. So what is a yield and a sleep? The yield keyword says after one loop, I'm going to allow other tasks to take control of the processor. I'm going to yield control of the processor after I finish this one execution. Whereas sleeping says, I've gone into some sort of wait state and you don't have to wake me up until there's some sort of interrupt or something occurs to make me have control of the processor again. So either way, when I'm working with multiprocessing, I may have code where I need to yield control and give other processes a chance to use the processor, or I might need to go to sleep. Think about something that's really processor intensive, like if I were doing, let's say I was doing some sort of rendering for some sort of 3D animation and I was just using that processor really intensively because I have all that data all loaded up into RAM. I don't need to do any I/O. I don't really need to show anything on the screen. If I go into some sort of execution like that, I can tie up the processor and prevent any other tasks from getting access to it. So if I have a really intensive resource that doesn't use a lot of resources but the processor, I may need to issue yield statement or go to sleep. Now I could also need to join a thread. Here I have two threads. Thread print 100, our little print 100 thread, is working away, and right now it is stuck in a wait state. It's waiting for thread 4 to finish. Thread 4 is over here working and working and working. When it finally finishes, it can issue the command to join, and it's going to join into that other thread so that now they're not running concurrently, they're running together, and it allows that first thread to continue execution.
Does this functionality allow you to take advantage of multi-threaded processors or that only in certain cases?
To do what?
To take advantage of multi-threading processors with that only?
Well, the multi-threading that takes advantage of it, it's going to take advantage of that, but it's going to depend on, you know, your operating system and your BIOS settings and things like that that you have set up too, as far as what its capabilities are.
So you could technically use Java.
Mm-hmm. Yeah. So it's a multi-threaded language, and that's one of the reasons, one of its big capabilities, that you can do multi-threaded processing. So here's an example of this running Java thread that I was talking about earlier. It's got the processor, and it's just doing calculation after calculation, and it's not letting go. So here this running Java thread has a hold of the processor. We have higher priority threads and tasks sitting there waiting. And way back over here, we have this little low priority guy. He's never going to get a chance. So we call that a starving thread. And that can happen. It's just sitting out there. Have you ever felt like you were a starving thread? And all of a sudden you press Control-Alt-Delete or something, and you're like, oh, magic, it took off. Look, it wasn't magic. You generated an interrupt. The interrupt caused something else to yield or go to sleep because this interrupt was generated. And now this poor starving task got a chance to jump in there. So sometimes when we do magic things, we're really not. We're just taking advantage of what's out there. Now, when we look at priority, every thread is assigned a priority by the Java virtual machine. So this is just within Java. That has nothing to do with other processes in the operating system, just all your Java threads. Now a thread is going to inherit its priority off of its spawner, its parent. The priorities range from 1 to 10, and there's constants available. So when we're coding, in our code, we can use things like min_priority instead of 1 or 10. And they recommend that you use those constants. Why? Well, because if the next release of Java decides that priorities range from 1 to 50, these constants will still work appropriately. They'll be updated appropriately. But if you had hard-coded numbers in your code, they wouldn't. So you would have to do some updating.
So if they're raising 50, your 10 is going to run.
Your 10 is going to drop. It's not going to be as high a priority as it used to be. Now we can use set priority and get priority to find out what our priority is and to set it. Yeah, this is where you guys get to really mess with the machine, so we don't get to do very much with it. Now, what's round robin scheduling? Just like that very first thread we looked at. A thread gets a little bit of time, the next thread gets a little bit of time, the next thread gets a little bit of time, and we just equally give everybody resources. That round robin scheduling is pretty effective. We use it a lot. A lot of processors use that for all their different tasks that they have going on. Just give it some time. But sometimes we can have some contention, like we saw. That one thread never getting a chance to use the processor suffers starvation. So a really high priority process must sleep or yield to allow other threads to complete. And you guys will see it. You'll be on some development team somewhere where somebody's like, no, I'm not lowering my processor priority. I get to do everything. I get to take it off. Okay, and if you look in your book, this is a really strong recommendation. There is a case study called flashing text. This very, very, very closely emulates the assignment that you have of raising the flag. Because as I mentioned, the Java FX stage must be on your primary thread. So that means if you're using a Java FX application and you're multi-threading, you have to somehow get back to that primary thread to update your Java FX GUI. And this flashing text shows you very much how to do that. So I recommend you looking at that case study. Since it's just a PDF, you'll have to kind of copy along or code along with it. There's no videos or anything for you. It's kind of old school. Okay, questions about multi-threading, multiprocessing before you guys take off for your working with your group project? Good, got it, got it. All right, I know you're gonna have some questions. You can just let me know. But I'm gonna end this and